Okay, welcome to the Auditory Learner. This third video for Histology Embryology is going to be on facial development, chapter 4, face and neck development, chapter 4, chapter 5, development of the oral facial features, tooth development eruption, and also chapter 7, which is the overview of the cell. All right. So moving straight to it, we're going to go to the development of the face and neck. But first, we want to just make sure we understand where the stomodium is, the first pharyngeal brachial arch or mandibular arch, the maxillary process, the frontal nasal process, and nasal pits, the medial nasal process, intermaxillary segment, and the lateral nasal processes. So we might end up having to draw this. So Daniel, remember that clay Play-Doh model we made. All right, so we're going to want to know that the top of the head of that thing that we created is the frontal nasal process, which is made by ectodermal tissue and also leads into the medial nasal processes, medial and lateral nasal processes. Those little two eyes in the middle, remember the inside of it is called the medial nasal processes. All right, then we have the holes of those two little things. Those are the nasal pits. Those are also called nasal placodes or nasal cavities, okay? Also, we want to make sure that when we're labeling this thing, we see where to label everything, okay? So the frontal nasal process, the origin is ectodermal tissue, okay? Again, and the future leads to medial and lateral nasal processes. Then we have the stomodium, which is that little hole in the middle in between those two little eye-looking things, which creates the oral cavity proper. And that also originates from ectodermal tissue, okay? We have the lateral nasal process, which is the outside of the circles there, okay? So that becomes the nasal alley, okay, the lateral. Then we have the nasal pits, which is those little holes in the middle. Those are the nasal placodes, and they become the nasal cavities. Then on the very outside of that is like the ears, but those are nasal placodes and nasal lenses as well. The first arch is the maxillary process. The superior anterior swellings from the mandibular arch, and it becomes the midface, upper lip, side cheek, secondary plate part. The second one is the mandibular symphysis, or right in the middle. Then the after the nasal process, the first arch is the maxillary process, and the second arch is the mandibular arch, which is the first pharyngeal of the brachial arch. Okay. And remember also above the stomodium, we have the intermaxillary segment. All right, so just imagine that little clay thing we made and everything we added to it, okay? Remember that the mandibular symphysis is below the stomodium, in between the maxillary process and the mandibular arch, brachial arches. Okay, again, continuing with that part of the face and neck development, we are going to talk about it again right now. So make sure we know that the overview of the facial development is the embryonic period. It begins at the 4th week, okay? And it ends at the 12th week. So the embryo at the 4th week, okay, it starts to look like that penis thing that I drew with my group. So again, we don't really see the nasal placodes completely yet on this penis looking picture, but remember I drew that. It was the developing heart that looks like a thumb coming up, the stomodium in the middle. The developing brain is the little bump on the very left. The lens placode is like the beginning of the eye. The nasal placode we can see at the 4th week. It's barely starting to show on the tip. And then we have the stomodium, okay? And the very top is the frontal nasal process. 5 prominences formed between the 4th and 10th week, which is the frontal and the 2 maxillary and the 2 mandibular ones. All right, so the frontal nasal process in the adult face is the forehead and the nose. The maxillary process is the zygomatic arch and the upper lip, and the mandibular is the lower lip and the mandible. All right, so overview of facial development. The fusion is when swellings or tissue on the embryo come together. All right, the facial fusion. And that just starts merging. And then once it starts merging, um, we'll see the separating of the furrow filling in, and then the merging is complete. We're going to keep going. Facial fusion, these arrows are usually eliminated as the underlying mesenchyme. So also make sure we understand the membrane that's also separates the symodium from the primitive pharynx. Okay. The oral pharyngeal membrane enlarges the stomodium of the embryo and allows the access between the primitive mouth and the primitive pharynx. So again, we see the picture of the labeling that we might have to label, which is the 4th week of the embryo. Again, we talked about it before. We made the clay pictures of that, okay? Don't confuse the lens plaque code with the nasal plaque codes, all right? Continuing on, the stomodium, but still within the 2 bulges of tissue appear inferior to the prima 2 mandibular processes. So that's good. We're going to just really quick go to my version of this because I might have had a better, more insight as to what we got to understand. So the primitive pharynx, again, the tongue of the throat. Remember light purple frontal nasal, purple max. Okay. The mandibular symphysis, indicating where the mandibulars form. Okay, all this we're gonna understand. So the 4th week is the big development of all this. Placodes are rounded areas of specialized thickened ectoderm. Remember, understand where the medial is the inner and the lateral is the outer. Okay. The nasal pits, these are the medial nasal processes. Intermaxillary segment is the medial and lateral nasal processes. Okay. Understand also that sometimes there can be a cleft lip during this formation, during the 4th week. This is where it becomes apparent. The intermaxillary segment and maxillary did not come together the way it could be, and then you can have a unilateral cleft lip or a bilateral cleft lip. Some people might have commissure lip pits, which is labial during the limbal commissure treatment. There's no treatment for that, but that comes from mesenchyme. Then we have the pharynx formation, which is the development of the brachial arches, still in the 4th week, the arches. Okay, and see if there's anything in here that's very important. The pharyngeal pouches and derivative structures. So the first pouch is the tympanic membrane, the second pouch is the crypt and lymphatic nodules, and the 3rd and 4th pouches are the parathyroid and thyroid glands. Okay, so that was really quick of the development of the face and the neck. Okay, development of the face and the neck, which is chapter 4. All right. Label that clay figure. I'm sure that we're going to have to know how to label those stuff. Okay. Now we're going to go to chapter 5, which is development of the oral facial structures. All right. I remember we had a test on this. Sometimes people can have ankyglossia, which is um, the connection of the ventral surface of the tongue to the floor of the mouth. Oral facial development happens later, embryonic to early fetal period, 4th to 12th week. All right. The formation of the palate starts during the 5th week of prenatal development within the embryonic period. We need to make sure that during the 5th to 6th week, we have the primary palate, which is the frontal nasal and the medial lateral and, the philtrum, etc., which is the intermaxillary segment form from fused medial nasal processes. That's the 5th to 6th week. The 6th to 12th week is the secondary palate. 12th week is the final palate. All right, all three come together at the 12th week. Again, we talked about this before. Fusion of the palate involves fusion of the swellings that come together from different surfaces to join. All right. During the 5th week, still embryonic period, the intermaxillary segment forms. Here, we want to make sure we understand from the inside going up view, the maxillary with the 4 incisor teeth comes first. All right, during the primary palate or the primitive plate. This is the time where the primary palate serves only as a partial separation between the developing oral cavity proper and nasal palate. Again, so the secondary palate forms at the 6th week. We might get this lateral view the bilateral view where it looks weird. This was a quiz, okay? We had to label this processes of the palatal shelves. All right, so there's like 3 pictures that look like a cross section through the side of a developing embryo, where I circled these 2 red things. Remember, the developing nasal septum is the top bulge. The stomodium is right in between the 2 bulges. Okay, and then that bottom bulge is the developing tongue. All right. The maxillary process is the stuff in between the top bulge. The palatal shelf is what's going to happen with the fusion when it comes together. You see those 2 little things. There's 2 palatal shelves that come together. And then they end up creating fusion of the palate. All right. So we might have to measure this. Remember the where the tongue is, which is the bottom bulge. The developing mandible is just before that. The developing nasal cavity is the top of the top bulge. All right. So the direction is downward, okay, then up. So it's down, up, then together, okay, down, up, then coming together. The secondary palate formation, okay. That is secondary palate formation. They grow inferiorly along both sides of the developing tongue. Perfect. The tongue is also forming the floor of the mouth, okay, and it develops the tongue through muscles. And so again, we're gonna have to make sure we understand that, okay? The stomodium, once the fusion comes together of the palate, I believe the stomodium is not there anymore, and that becomes the oral cavity, okay? It'll be right below it. The stomodium is the space between before it fuses, all right? So we're gonna keep moving forward with this. Sometimes what can happen is an Epstein pearl, which is a small white papule seen in the midline of the palate of an infant. It represents the epithelial tissue that becomes trapped during palatal fusion. Completion of the palate, a posterior part of the primary palate meets the secondary palate. Again, make sure we understand that. So 5th week primary palate, 6th week secondary palate, okay? And ends at the 12th. All fusion is done of all 3 processes at the 12th week. So 5th week primary, 6th week secondary, all right? Again, we're talking about cleft palates. or cleft lips, failure of fusion, okay, of the palatal shelves, cleft lip or cleft bladder or both. Um, that can happen for bad fusion during the 6 to 12 week. People can have unilateral, bilateral. People can also have a cleft uvula or a bifid uvula, which is again failure of fusion between the nasal and maxillary processes. So we're going to keep going here. Development of the nasal cavity and septum. The nasal cavity forms in the same time frame as the palate. Okay. Um, One thing we need to understand: the nasal cavity and the septum development. The tissues that form the nasal septum will grow inferiorly and deep to the medial nasal processes. So down and in between the medial nasal processes. Okay. That's the nasal cavity and the septum development there. That's why sometimes we can have people with deviated septums, which is the midline is kind of off-centered when you're looking at the nares. Um, Occurs when the thin wall makes up the nasal, a thin wall that makes up the nasal septum inside the nose is displaced to one side. The nasal septum separates right and left nasal cavities and ideally situated in the center of the nose equally. Okay. Interesting how we see a CT scan of a nasal septum. Um, Tongue development develops during the 4th to 8th week. Okay, it develops from independent swellings located internally before the mouth in the primitive pharynx, formed first by the brachial arches. So we kind of talked about that on that picture there. We might have to label the bottom, the bulge being the tongue. But I see here it also takes 8 weeks for soft tissue tongue grows faster than the palate. Tongue grows faster than the palate. All right. Time period with tongue parts involved is 4th to 8th week. All right. The body of the tongue, the tuberculum impar, and the lateral lingual swellings appear. The copula is overgrowing. So tongue and floor of the mouth are the worst places to have issues. All right. By the 8th week, the tongue is completed. So again, remember there's like 6 brachial arches. The tuberculum impar, the tongue development begins as the triangular medium swelling, the tuberculum impar, which is in between the first and second pharyngeal arches. It's this little ball in the middle. That's a tuberculum impar. Okay. It also looks here like the first arch that we see is the mandibular arch. The ball below the tuberculum impar in this labeling image of the arches on chapter 5 is the copula, okay? And then the bulge below that is the epiglottic swelling. Okay, the 2 lateral lingual swellings, okay, with the median sulcus, lingual sulcus superficial demarcation between the 2 lingual swellings. Lateral lingual swellings, all right? So that's basically the top of the first pharyngeal arch. Those are the lateral lingual swellings right there. The base of the tongue is the copula, again, that little middle bulge. Remember that mesenchyme comes from neurocrest cells, okay? We're gonna keep moving forward here. Completion of the tongue happens during the 8th week. Remember that, during the 8th week. One thing that we're gonna need to understand too, completion of the tongue, the fusion is superficially demarcated by the sulcus terminalis. Okay, the sulcus terminalis, which is after the circumvallate papilla, the middle of the tongue, the sulcus terminalis. Okay, and then the foramen cecum. Well, that is the foramen cecum, which is the start of the thyroid tract. Okay, the first brachial arch, all right, the mandibular. This is the pathway to the thyroid of the gland. Thyroid, okay, so the word thyroid is there. Beginning of the thyroglossal duct starts with the foramen cecum, okay, at the completion of the tongue formation. starts in the thyroid tract. All right. Some other things that we're reaching here. Ankyloglossia is tongue-tied. Okay. It's a short attachment of the lingual frenum that extends to the base of the mouth. Cool. So that was chapter 5. Chapter 5, module 2, critique of the tongue. Let's see if we can understand some other stuff here. Yeah, so here again, something that's really helpful for tongue development, right? You have 6 arches in total. All right, that's the main thing I'm seeing here. Okay, we have first arch, second, third, fourth, fifth, sixth. Okay, the sixth is where the tracheal groove begins. We want to just make sure here. So number 1, first pharyngeal arch, first, second, third, fourth, fifth. Okay, sixth. Very good. The foramen cecum is number 3. All right, so the foramen cecum is just below the lingual swellings. Okay, so just kind of remember that thing. That because we might have to label this as well. All right. Let's just make sure we know what arches we're going to label if we have to. Okay. Don't want to stop wasting time. The arch, the mesoderm, is the top outside layer. Okay. Pharyngeal arch number 1, foramen cecum, medium tongue. Okay, perfect, perfect, perfect. Give me the names of these arches, somebody. So number 1 is mandibular. Okay, I'm assuming because the maxillary is the frontonasal process for sure, if I'm not mistaken. All right, formation of the tongue. Lingual swellings with the tuberculum impar give anterior 2/3 of the tongue. Right, the copula, mesoderm between both first and second arches give anterior 2/3 of the tongue. All right. Just kind of spreading out over here, chapter 5, making sure, because there's a lot of information. So pharyngeal grooves are the outside, pharyngeal pouches are the inside. All right. Grooves outside, pouches inside. Yes. That's going to be perfect there. Perfect. So we're just gonna stay with that. This is a waste here. Okay, now we're gonna go. So that was, if I'm not mistaken, development of oral facial features, which involves the tongue. Okay. Now we're gonna go to chapter 6, which is tooth development. All right, and we're just going over the slides here. So we want to make sure that we understand the initial tooth development is the initiation stage, bud stage, cap stage, bell stage. All right. And then it's stages of apposition and maturation. So it goes, tooth development is initiation, bud, cap, bell. All right. Then we go through apposition and then maturation. Maturation is when, it varies by tooth. That's when we start to see the tooth starting to actually come out of the gum or tissues. All right. Tooth development, it starts within the 6th to 7th week during the embryonic period through odontogenesis. Primary dentition begins during the 6th and 7th week, all right, during the embryonic period. Something we need to know is sometimes you might get a tooth where the bud is very close and there's fusion or gemination. All right. Ectoderm becomes oral epithelium. Neural crest cells form the ectomesenchyme. All right, triggers tooth formation in the stomodium. So this is the initiation stage we're talking about, which is the epithelium and connective basement membrane that happens in the stomodium. And again, initiation stage, week 7, we start to see the dental lamina. All right. Some disturbances during the initiation stage, all right, is when we see anodontia, um, or lack of initiation within the dental line results in absence of a single tooth or multiple teeth or produces anodontia. Partial anodontia is hypodontia, which is more common. Permanent maxillary lateral incisors, third molar. So some people might be missing some teeth, all right? So if you're missing teeth, or you get too many teeth, that happens during the initiation stage. Um, Ectodermal dysplasia is they never had initiation. Okay, they look kind of like little vampires. Um, Also, what can happen is too many teeth during the initiation with supernumerary teeth, which is initiated by the dental lamina. There's a hereditary etiology there. So one thing to understand is the mesodens is between the maxillary central incisors. A distomolar is having a fourth molar, so even beyond the third wisdom. And then a perimolar is something that happens like buccal on the buccal or lingual of a premolar. Okay, so mesodens is between 8 and 9. It's like a tooth between 8 and 9, between the maxillary central incisors. A distomolar is a fourth molar, and a perimolar is on the buccal or lingual side of premolars, an extra one. These are all again during the initiation stage. Okay, so now initiation has started. Now we have the bud stage, which is the second stage. All right, week 8. It's proliferation happens. It'll be about 10 buds. All right, which for each tooth, maxillary arch, mandibular arch. So that's 20 teeth that the primary teeth are. Okay. A peg lateral. Okay, if somebody has a peg lateral, that's going to be during the bud stage. All right, microdontia is a peg lateral. Macrodontia, huge teeth. Then there's the cap stage, which is the third stage. This is probably going to be on the test because we were told very explicitly that we need to be able to learn what to label. All right. So what I'm seeing here is an image of what's probably called a tooth germ, which is made up of many different layers. Okay, it's the proliferation and differentiation of the enamel knot, enamel organ, dental papilla, dental sac. So we're going to need to know how to label that, I'm sure. So again, what we're going to see here is uh, the cap stage, which is like the tooth is starting to grow inside the pharyngeal arch here in the stomodium, I'm assuming, of the epithelium. Okay, so the most outer red layer, the most surface covering outer red layer, that's called the dental sac. All right, and then there's the dental papilla, which is the middle or the inside of that outer most reddish layer. And then there's the enamel organ, which is the white stuff, the big white stuff in the middle. All those three things together create the tooth germ. All right. Now, the enamel knot is also technically inside the tooth germ, but it's the thing that outlines. So it looks like epithelial tissue. So that's the enamel knot. So the enamel knot is, I would say, to remember that, the outline of the tooth germ, okay? Or the enamel part of it at least. So again, the most outer dental sac, the middle inner papilla, And the enamel organ is actual, all the white stuff. The enamel knot is the outline, okay? And the developing mandibular bone is everything outside of that. So the enamel organ, again, we are in the cap stage, okay? Um, this is where, again, the dental papilla will produce the dentin and the pulp. The cap stage, the remaining ectomesenchyme surrounding the outside of the cap or enamel organ condense into dental sac. The outside is still ectomesenchyme. All right, so the initial tooth germ will develop into the primary dentition. Tooth germ components during cap stage, enamel, dental papilla, dental sac. All right. Enamel organ, future enamel, dental papilla, future dentin and pulp, dental sac, future cementum, dental ligament bone. Make sure we know succedaneous versus non-succedaneous. I'm going to take a shot here, and succedaneous meaning that there are certain teeth that come after another one into the permanent stage. Some baby teeth are non-succedaneous because there's nothing that's going to come after that. It's just one, okay? The site of origin is called successional dental lamina, all right? So that means they're going to get a permanent tooth. They're succedaneous. Permanent teeth formed with primary predecessors are called succedaneous. Yes, permanent molars are non-succedaneous. There's no primary predecessors. Okie dokie. Okay, so understand that. I'm going to repeat what I just said. Permanent molars are non-succedaneous because they don't have primary predecessors. That sounds right to me. All right. So now during disturbances during the cap stage is an enamel organ or dens in dente or dens in vaginatus. It's hereditary to the dental papilla. It's just like a malformation of the root or tooth. It looks like an infection sometimes, but it has a very abnormal abnormality, usually in the lingual, or looks like two teeth didn't come together correctly there sometimes. Another disturbance during the cap stage is gemination, which occurs as the single tooth germ tries to unsuccessfully divide into two. So it looks like one tooth tried to become two, but it didn't. So it results in a large single-rooted tooth with a common pulp cavity, all right? So gemination looks like it was trying to split in two, but it didn't. Fusion results from the union of two adjacent tooth germs, leads to a broader, falsely macrodontic tooth. All right, so sometimes you might see two teeth fused together. That's during the cap stage, okay? Teeth may also have tubercles or extra cusps. All right. Now the bell stage, all right, is the fourth stage. Again, be able to label these images here. All right, we have the enamel organ, which is the white stuff. During the bell stage, it looks more like a bell now that we see that. We'll also see the outer enamel epithelium, which was back the outer enamel epithelium, the OEE, actually was, if I'm not mistaken, the enamel knot before. But now that we're in the bell stage, that enamel knot has turned into the outer enamel epithelium, okay? The outlining thing. So we have outer enamel epithelium, and then we have inner enamel epithelium. Then again, the red stuff is the dental papilla, the white stuff is the enamel organ. All right, so inner enamel epithelium is on the right side, outer is on the left side. Okay. The stellate reticulum is the enamel organ. All right. And the stratum intermedium is that red stuff inside the enamel organ. So the outer cuboidal cells of the enamel organ are enamel epithelium. The innermost taller columnar cells are inner enamel epithelium. Okay. This is very, very, very long. Okay. They're in this apposition and maturation. All right. And we're just going to keep going with this because this is an unbelievable amount of information. But we did talk about this. The ameloblasts create the enamel, amelogenesis. This is the enamel matrix. Enamel matrix is secreted from Tome's processes and an angled part of the ameloblast that faces the disintegrating basement membrane. All right. So during formation of ameloblasts, create the dentin enamel junction. All right. Formation, the odontoblast, and we'll have the predentin is the odontoblast, the dentinal tubular. Moving again forward, this is so much information. Enamel hypoplasia is caused by febrile illness or vitamin deficiency. Dental fluorosis, we talked about that. We're going to just keep going. Dentinogenesis imperfecta sounds bad. We heard about that. We're just going to keep going here because it's just so much. The root development over time. Okay. So we're going to just kind of skip this because it's so much. One thing here during active eruption, there's the 4 squares of the tooth coming out during the maturation stage. We're going to need to label that. So remember that the reduced enamel epithelium is just those 3 layers of the enamel. Okay. Oral epithelium is the gum looking stuff. The connective tissue is just the outer layer of the tooth. And then the enamel is the blue thick layer under the reduced enamel epithelium, and then below that is the dentin. Okay. Make sure we understand that. Yes. Make sure you understand what a dentigerous cyst is, or follicular cyst, that forms from the REE, reduced enamel epithelium, after the crown has completely formed. So that can happen with impacted molars. So again, understand chapter 6, tooth development. We're going to review that more. Then we're going to go over the overview of the cell stuff. All right. And the overview of the cell is just quite simple as well. Make sure we understand what a cell is, right? There's a lot of organelles, including the nucleus, the mitochondria. There's a phospholipid bilayer. There's the Golgi complex with the lysosomes. There's the rough endoplasmic reticulum, the centrioles and the centrosomes, and the cytoskeleton with microtubules or the cytoplasm. So cells are the smallest living unit of organization. Tissues is a collection of similarly specialized cells like epithelium and nervous tissue, muscle, cartilage, bone, connective. Organs are independent body parts formed from tissues, skin, brain, heart, liver, and then the systems are the organs all functioning together. So smallest to biggest, smallest cells, then the tissues, then the organs, then the system, which is all the organs with all the tissues and all the cells. So the nucleus, we have the nucleolus, which is the nucleus of the nucleus. Then we have the border of the nucleus, which is the nuclear envelope. There's nucleoplasm, which is the jelly inside. Then there's chromatin, which are the stringy things, and the nuclear pore, which allows for stuff to come inside and out. Interphase occurs with chromatin, and they come together, and then the nuclear envelope, and there's a centriole. Again, mitosis, my 2 sisters, because it goes from interphase, prophase, metaphase, anaphase, telophase, and then there's 2 daughter cells. 1, 2, 3, 4, 5, 6. Mitosis ends up with 2 daughter cells. Meiosis, 1, 2, 3, 4, 5, 6, 7, 8. So it's interphase, meiosis 1 and meiosis 2, and then there's 4 daughter cells. All right. Phagocytosis, we know what happens there. It's the white blood cells attacking foreign substances or objects. Lysosome containing lysosomal enzymes. We know desmosomes and hemidesmosomes now as well. Hemidesmosomes, I believe, bring 2 different types of tissue layers together. Desmosomes bring the same type together. So you already know that there are tonofilaments, which are the things that are attached to the plaque, attachment plaque, and then the attachment plaque is what attaches to the membrane. Okay, and then there's the linker proteins that bring things together. That's specifically for the desmosomes. So that was chapter 7. All right, so we just went over module 2, development of the face and neck, oral facial features, and the next video will be module 3. So before we end, let's just make sure there's nothing else to talk about for this, because all right, embryologic development, the group assignment, I remember this. So one thing again, remember the sperm and the ovum, day 1, zygote, mitosis, cleavage happens, day 2, 2 cell, day 2, 4 cells, day 3, 8 cells, day 4, morula, day 5, blastocyst, and then blastocyst has inner cells, and then that starts implantation at day 6, okay? Again, so just to review, week 1 is the pre-implantation period that we just talked about. Week 2 is the bilaminar disc. All right. Week 3 is the formation of the primitive streak and gracillation, which creates the trilaminar disc. All right. And then again, between week 3 and 4, we have face and neck development happening as well. Again, the trilaminar disc has undergone embryonic folding during week 4 with the formation of the nervous system via the somites to produce the tubular embryo. All right, so again, the frontal nasal process, the lens placodes, the stomodium, the maxillary process, mandibular arch, and mandibular symphysis, which is under the stomodium. All right. We have, again, palate formation between 4th and 6th week. Okay, just to review. And yes, we kind of went over the tongue development again. Okay, so that's that. Hopefully that's valuable. And great, we'll end it there. That's module 2, chapters. Module 2 is chapter 4, 5, 6, and 7. All right, development of face, neck, oral features, tooth eruption, and the overview of the cell. Thank you.